All right, hey pre-calc kids, we're back with Unit 2 for the calculator active homework with questions created by Mr. Passwater. So on question 15 here, we have a binomial theorem question. So we want to expand 2x plus y all to the fourth power. And again, like you could multiply that out. Like you could do 2x plus y, multiply that out 4 times, but that's going to take us a really long time. So we learned something called the binomial theorem, and we have to use Pascal's triangle to help us get the coefficients of each of our terms. So just a little refresher on Pascal's triangle. If I have something to the 0th power, my coefficient on that would be 1. Something to the 1st power, 1, 1. Something to the 2nd power, 1, 2, 1. Something to the 3rd power, 1, 3, 3, 1. And again, we get this next row of numbers from like adding the 2 above it. So like 1 plus 2 gave me 3, 2 plus 1 gave me 3, and then our outsides are always 1s. And then we have something to the 4th power because we want to raise 2x plus y to the 4th power. So my coefficients are 1. Again, 1 plus 3 is 4, 3 plus 3 is 6. 3 plus 1 is 4, and 1. So these are the coefficients of my terms that I'm going to use whenever I multiply. So it might be a good idea to just like leave yourself some space. So like 1, and then 4, and then 6, and then 4, and then 1. These are my coefficients of my terms. And then we can go ahead and our first term of 2x, that is going to go in descending order of starting with a degree 4. So I would need to raise 2x to the 4th power, 2x cubed, 2x squared, 2x to the 1st, and 2x to the 0th power. Then our other term, this y, we're going to go in ascending order. So I'm going to start off with y to the 0, and then y to the 1st, y squared. And this is just something that, I guess mathematicians invented to help us not actually have to multiply this out 4 different times, because that would be very cumbersome. So just a quick little thing you can check yourself. The degrees of your first term and second term, like whatever your power you're raising it to, should always add up to 4 in this case, because we're raising it to the 4th power. So notice 4 plus 0 is 4, 3 plus 1 is 4, 4, 4, 4. So we're adding all of these terms together, so I guess we can put a little plus sign between them. And then let's start. I don't think we actually have to multiply this out. I'm not actually having to raise 2 to the 4th power because it looks like my answer choices are still not all the way multiplied out. So I'm just going to simplify each term. Y to the 0 is just 1, so that leaves me with 2x to the 4th, plus simplifying my next term, y to the 1st power is just y, so I have 4 2x cubed y. And again, maybe they might make you cube out the 2 and cube out the x, but I can tell based off of our answer choices we're not having to do that for this question. Simplifying this, I got 6 2x squared y squared, plus simplifying this. Again, they didn't even multiply out the 2 with the 4, so we could multiply out the 2 and the 4, but it looks like they're not even doing that on my answer choices. So 4 2x y cubed, and then plus simplifying this, 2x to the 0th power is just 1, so this simplifies to just y to the 4th. Our answer is gonna be, looks like C from our answer choices. Okay, this is another one of those binomial theorem questions. So again, I'm going to want to look at my Pascal's triangle. So I want to go all the way to the 4th power. So this is starting on the 0th. So this is 1st, 2nd degree, 3rd, and 4th. So these are the lines of coefficients that I want. Those are going to be my coefficients, like 1, 4, 6, 4, 1. and first term, I'm going to go in descending degree. So x to the fourth, x cubed, x squared, x to the 1, x to the 0. And then for my other term, this minus 7, I'm going to go in ascending order. And you do have to take that minus sign with it. So since it's negative, I need to go negative 7 to the 0, negative 7 to the first, negative 7 squared, negative 7 cubed, and negative 7 to the fourth power. Okay, so now I have each of my terms. And this question is not even asking for the full answer, but it's just asking for the coefficient of the x squared term. So I don't really care about this, I don't care about this, don't care about that or that. I'm only caring about what is going to be the final result coefficient here. So I can see that I have negative 7 getting squared and I have a 6, so that looks like answer choice B. Now granted, they might also make you multiply that out, so you can do 49 times 6 and see what that coefficient would be if it actually has you simplify that. Okay, now we're getting into some even and odd functions. So we have this table of inputs and outputs, and I can see off the bat I need to tell, is this an even function or an odd function? So just a little review for even and odd functions. For an even function, if I plug in an opposite x, like negative x, I'm going to get the exact same y value that I would get if I plugged in the positive version of that. So that means like if I plugged in negative 2 as my input, I'm going to get the exact same y value that I would get from plugging in a positive 2. So if that's true, we know that this is going to be an even function. And a way that we might have like thought about that whenever we learned this back in first semester is like opposite x's gives you the same y. Right? You can plug in opposite inputs, but you're still going to get the same output. Whether I plug in negative 2 or plugging in positive 2, I'm going to get the same y value. Whereas for an odd function, if I plug in an opposite x, I'm going to get an opposite y value. So like if I plug in negative 2 to an odd function, I'm going to get the opposite y value that I got when I plugged in a positive 2. So again, opposite x's or opposite inputs is going to give me opposite y's. So if I got a positive 3 from here, I'm going to get a negative 3 from plugging in a positive 2. So that's just a quick little review of even and odd. So let's see what we have going on in our function. If I plug in a negative 5, and I get out a negative 1. If I plug in a positive 5, I still get out a negative 1. So I plug in opposite x's, but I'm still getting the same y. That looks like to be an even function to me. And then furthermore, if I plug in a negative 3, I get a positive 8. If I plug in a positive 3, I still get a positive 8. So again, opposite x's give me the same exact y value. So opposite x's, same y value, means this is going to be an even function. We know that for sure. If it's an even function, then we know that plugging in an opposite x value or an opposite input should still give me the same y value. So the thing that we can conclude from here is even if I plug in negative 4, I'm still going to get the same y value, right? Opposite x still gives me the same y. So that is going to be answer choice D. All right, I think we can move on to Unit 3 and 4 because we put most of these questions on your no calculator homework because there's not much you can do with a calculator. Notice we haven't even used a calculator yet. We have a rational function with a 0 at x equals 5 and a vertical asymptote at x equals negative 2. Which of the following could be an expression? Okay, if I have a 0 at 5, I know that I have to have x minus 5 in the numerator, and it cannot happen again in the denominator, because if it was also in the denominator, then it would either become a whole or a vertical asymptote. If I have a vertical asymptote at x equals negative 2, then I have to have x plus 2 in the denominator, and it cannot... I guess it could appear in the numerator, but it would have to appear more times in the denominator in order for it to turn into a vertical asymptote. So this is what I'm looking for. And I want to say like this cannot be in the denominator. So I don't even have x minus 5 in the numerator here, so that's wrong. Good, I have x minus 5 here, and I also have x plus 2 here, so I'm liking this answer. I have x minus 5 in the top and bottom, so that is wrong. That's either a whole or vertical asymptote. In this case, that would be a whole. And then here, I'm missing the x minus 5 from the top, so it definitely can't be that. So we're good with answer choice B. All right, unit 4. We have a graph of h. Which of the following conclusions is possible? So we're looking, is this logarithmic or exponential? Okay, I think we can look at this and see that it's pretty exponential, but we really need to look at like what's proportional. So if I start at a point at 1, 1, I have another point at 2, 2, I have another point at 3, 4, and we can't really see much more, but I'm just going to assume that that's at 0, a half. Maybe that's right, maybe that's not. But I can see if I go up by 1 x value, I'm multiplying by 2 in my outputs. So that has to be exponential, definitely exponential growth. It's not logarithmic, it is exponential growth because my outputs are proportional over equal length input values. Yes, my outputs are getting multiplied by something, so that means that they are proportional. All right, again, seeing if it's exponential or logarithmic, let's just look at some points we have. So I have negative 2, 4. I have negative 1, 2, 0, 1. And I don't want to assume anything further. If I go up 1 in my x values, notice I'm multiplying by a half in my y values. So that's going to look like exponential decay. Not logarithmic, it's going to be exponential, again, because my outputs are proportional over equally spaced input values. So I think on here, you just got to be careful in the wording. Like, are your outputs proportional or are your inputs proportional? Because if my outputs are proportional, it's going to be exponential. But if it were flipped and if my inputs were proportional, then that would be logarithmic. Okay, I think I'm going to stop this one here. I'll do the next units in a future video.